Okay, so today we're going to talk about modules, which are a new language feature that we haven't talked about yet. And the idea of modules is that we want to divide the program up into chunks and limit which chunks interact with each other. And for chunks that do interact, we want to specify their interactions with what's called a signature. Okay, so what we're going to be thinking about is how to write bigger programs than we've thought about before. So up until now, our programs have mostly been like at the level of a function or a couple of functions or something like that, right? But now that you're looking at the Barnes Hut homework for next week, you're working on some bigger code. And the things about the issues that come up when you're dealing with bigger pieces of code are a little bit different than when you're just writing like one function or two functions and at a time. So when you're thinking about bigger pieces of code like this, you want to be thinking about the fact that like you can't entirely hold the whole program in your head at once. And so you're going to have to find a way to manage the complexity of the fact that you can't really think about all of the code all at once because it falls out of your brain because you don't have enough space in your brain for holding all of this stuff. When you get to like, real industrial scale software engineering, you're going to have millions of lines of code or tens of millions of lines of code, you're not going to be able to think about all of that at once. So what do we do to manage this complexity? Well, kind of the only thing we can do is we can manage the complexity by a divide and conquer kind of strategy where we take the program that we want to think about and we divide it up into chunks, and then we only think about one or two chunks at a time, and hopefully that's enough to get the job done. So in order to make it so that we can get the job done, thinking about only one or two or three or four, some manageable number of chunks at the time, is that we divide the program up into pieces, which hopefully we can understand individually. And so the chunks are called modules, or in SML, like the keyword is structures. And if every chunk of code could, like, refer to every other chunk of code willy-nilly, then this wouldn't really help at all because you'd sort of still have the complete graph and you'd have to think about all the code at once. But if instead you can limit which chunks of code talk to the other chunks of code, then you can get some simplification here. And so the way you limit that is that you specify their interactions with what's called a interface or signature, is the SML keyword for that, which basically says, here's what's in this chunk of code without actually making you pay attention to all the details of exactly how all of the code works. Okay, so why do we do this? Well, there's a few different reasons. One is that make it easier to understand. So if you're coming into a new code base and it's got like many, many, many things in it, then one way to make it easier to understand is to divide it up into these chunks so that you can just understand a chunk at a time. And the other thing is you'll start to be able to read these interfaces or signatures, or sometimes people call them APIs, which is jargon for application programming interface. Like you'll start to get used to writing code where you read the APIs or the interface or the signature of some code, but don't actually know what's going on behind the scenes. So you can make code easier to understand by making it so that you don't have to understand all the details. You sort of get a high level view of an abstract model of what's going on and program relative to that. Another reason is that you can do separate client and implementation evolution. So the idea is that, like, one way to picture it is that you sort of have module 1 that's separated by an interface from module 2, and maybe we'll think of module 1 as the implementation of the interface and module 2 as the client of the interface. So we'll do some examples in a little bit, which will make this clearer. But the idea is that, like, sometimes you're writing code that provides some stuff, and other times you're writing code that uses some stuff. And so the implementation is the one that provides some stuff, whereas the client is the one that uses some stuff. And of course, it's all relative, because the implementation of something might use something else in order to provide something new. So really, there'll be like a whole chain of these things kind of going on in either direction. We'll see the example from the Barnes Hut homework in a minute. But the idea is that when we're thinking about two modules specifically, or a few modules, we might think of one as implementing some interface and others as being clients of that interface. And so if you've kind of cut things along an interface and said, this is all that module 2 knows about module 1, then you can change module 1 without changing module 2 sometimes, and you can change module 2 without changing module 1 sometimes. So in particular, if you want to make a change to module 1 that doesn't change the overall behavior that module 2 sees, but, for example, maybe makes things faster or makes things use less memory or something like that, then you can make that kind of change without touching the code in module 2 at all. And if you want to change module 2 to use a different implementation of the same interface, then you can make that change without touching module 1 at all. You just write another implementation. Okay, another thing is that you can localize reasoning about invariance. So we'll talk about that a little later. And you can catch more bugs at compile time. So if you think back to last Wednesday's videos where we were talking about points and vectors, it turned out that both points and vectors were pairs of numbers under the hood. But conceptually, we wanted to differentiate between points and vectors. For example, it didn't make sense to add 2 points. So if you ever do that in your Barnes Hut code, that should be an error rather than like letting you do it and just calculating something that's kind of meaningless. So one of the things that modules let you do is they give you an idea of in your interface, you can specify what's called abstract types or unknown types. And the idea is when you have an unknown type or an abstract type, then the client, the stuff in module 2, doesn't know what the type is, doesn't know how it's implemented, it just knows that there is some type supporting some operations. So when you get to that situation, the idea is you can impose finer distinctions than just the fact that, like, under the hood, these are both pairs of numbers. So even though we had things that were pairs of numbers under the hood, we can present a view to the client where they look like two different things. And because they look like two different things to the client, if you try to, for example, use a point where a vector is expected, it'll error rather than succeed. Okay, so all right, so that's kind of the big picture. The big picture is that we're going to talk about the means for writing bigger programs by dividing them up into chunks.